Now we are discussing about design of FIR filter using Windows. In the last session we have discussed about the frequency response of linear phase FIR filters. 4 cases we have discussed now. Design of FIR filter using Windows. So the digital filters are having a transfer function like this. H of z is equals to summation n is equal to 0 to infinity h of n into z power minus n. And I am adding d suffix here because I am considering it as a desired transfer function, desired impulse response. So if I do the Fourier transform, I will get n is equal to 0 to infinity e power minus j omega n. And if I will do inverse Fourier transform to get hd of n, hd of n is equal to 1 by 2 pi integration minus pi to pi, this is 1, h of e power j omega, that is hd, desired frequency response, e power j omega n into d omega. So which is a Fourier series and it is of infinite length. So always we know that a causal linear time invariant system will have the linear phase if and only if its impulse response h of n is symmetrical or anti-symmetrical around n is equal to plus or minus n minus 1 by 2. Okay. So to get FIR filter response, first truncate the infinite Fourier series at n is equal to plus or minus n minus 1 by 2. Because it is infinite length but linear phase response we will get if and only if the h of n is symmetrical or anti-symmetrical around plus or minus n minus 1 by 2. This is nothing but finite length, but we got infinite length, so we have to truncate this infinite series into finite series. So this truncating done by window techniques, because why we are going for this windowing techniques, why can't we truncate suddenly from infinite to finite? If we truncate the series from infinite to finite series, there will be oscillations in the stop band and the pass band, so these are not desirable. So that's why we are going for windowing techniques. These windowing techniques will reduce this number of oscillations in a pass band and a stop band. Okay, so the window sequence can be written as like this: in between n minus 1 by 2, that is 0 if it is greater than n minus 1 by 2. So here, so how we truncate the finite series into the infinite series into the finite series means this hd of n is of infinite length, so we'll get finite impulse response by multiplying the desired impulse response with the window sequence. Okay, infinite series is multiplying with a window function which is of finite length, that is in between n minus 1 by 2 plus or minus n minus 1 by 2, such that I will get finite impulse response. So multiplication in time domain leads to the convolution in frequency domain. hd of e power j omega convolved with e power j omega. And now I am discussing about rectangular window. The name itself, it is saying the shape of the window is rectangular. If I consider capital N as 7, so it is minus 3 minus 2 minus 1 0 plus 1 plus 2 plus 3, like this I will have, and its magnitude is equal to 1. So the rectangular window sequence can be represented by W R of n. Actually window is W of n, The suffix r is nothing but it is a rectangular window. So WR of n is equals to 1 for minus n minus 1 by 2 plus n minus 1 by 2, and it is 0 otherwise. Okay, so now I want to calculate the spectrum. So that is Fourier transform formula. N is equal to minus n minus 1 by 2, because it is having the limits between plus or minus n minus 1 by 2 into e power minus j omega n, h of n into e power minus j omega n. So this is having the magnitude 1, so h of n is 1, and it is e power minus j omega n. Okay, now I am changing the limits from by changing the variable. Okay, so I am considering the variable as k is equal to n minus 1 by 2. From here n is equal to k minus n minus 1 by 2. So if n is equal to minus of n minus 1 by 2, or if n is equal to n minus 1 by 2. If n is equal to n minus 1 by 2, if I substitute here, n minus 1 by 2 minus n minus 1 by 2. So from here I will get k is equal to 0. If I substitute minus of n minus 1 by 2 minus n minus 1 by 2, I will get k is equal to n minus 1. Okay. So now WR of e power j omega is equal to summation. The limits are from k is equal to 0 to n minus 1 e power minus j omega. What is n? K minus n minus 1 by 2. Now changing the variable from k to n, I am having n is equal 0 to n minus 1 e power minus j omega n minus 1 by 2. So I will write it as e power j omega n minus 1 by 2. I am bringing this n minus 1 by 2 outside of the summation. N is equal 0 to n minus 1 e power minus j omega n. Okay, so this is the equation, and for this summation n is equal 0 to n minus 1 e power minus j omega n, that is summation a power n, where n is equal 0 to n minus 1. Summation n is equal 0 to n minus 1 a power n. Formula is 1 minus a power n by 1 minus a. Like this, 1 minus e power minus j omega n by 1 minus e power minus j omega. If I multiply this inside, e power j omega n minus 1 by 2 minus e power minus j omega n plus n minus 1 by 2 n minus by e power j omega n minus 1 by 2 minus e power minus j omega into e power j omega n minus 1 by 2. Not like that. So here e power j omega n minus 1 by 2 is here. So e power j omega n minus 1 by 2 into 1 minus e power minus j omega n by 1 minus e power minus j omega. So this can be written as e power j omega n by 2 by e power j omega by 2, and it is e power minus j omega n divided by 1 minus e power minus j omega. So after simplification, I will get e power j omega n by 2 minus e power minus j omega n by 2 divided by e power j omega by 2 minus e power minus j omega by 2. E power j theta minus e power minus j theta can be written as sin theta e power j theta minus e power minus j theta can be written as 2j sin theta, 2j cancel, sin omega n by 2 by sin omega by 2. So sin omega n by 2 by sin omega by 2 is nothing but a sinc function. And the sinc function will have the characteristics like this. So this is a main lobe width, this is 2 pi by n, this is 2 pi by n. So for the rectangular window, the main lobe width is 4 pi by n, and these are nothing but side lobes. Okay, so here the side lobes height, this is a side lobe, this is a side lobe, so this is a side lobe, this is a side lobe. So this height is 22% of the main lobe height in rectangular window. And as capital N is going on increasing, width decreases. The width is very less and it will have more energy that is desirable. So as order is going on increasing, width is going on decreasing, and the more energy will lie in the central lobe that is desirable. Thank you.